everyone. We are going to talk about metadata and what's in the future of metadata for Prometheus. I'm Ganesh Vernekar. I'm a Prometheus maintainer, and I have been contributing to Prometheus for over 6 years. And currently, I am also working on the Mimir project, so I try to give how much of time I can for Prometheus.
Hello, everyone. I'm Arve Knudsen. I'm a senior software engineer with Grafana Labs. I work on Grafana Mimir, but I'm also a maintainer mainly of the OTLP endpoint in Prometheus. So, as Ganesh said, we are going to talk about our idea for persisted metadata in Prometheus. So, first of all, what do we mean by metadata? So basically, the idea is that we associate each time series with a collection of key value pairs, really, and this collection per series of key value pairs can change over time because metadata for time series can change. And then there's a question: why is there a problem to solve? For starters, we have the existing concept of metric metadata in Prometheus, where you can describe a metric's type, its unit, its help, but the drawback is that or the limitation, I mean, is that it's currently only stored in memory and not persisted in long-term storage. And in addition to just metric metadata, there are emerging use cases like open telemetry resource attributes. So for those of you who are not familiar with open telemetry, every metric in open telemetry that Prometheus receives is associated with a so-called resource, and a resource basically represents the entity producing the metrics, and then the resource has a collection of attributes describing it, and the attributes are basically a collection of key value pairs. So they are now encoded via an info metric in Prometheus, but we think that if we had natively persistent metadata directly in Prometheus, that would be a better way of modeling and storing these attributes. There's also the use case of attaching custom metadata to series, where now people will solve this by adding labels to series, and then there's the use case of storing things like created timestamps for series, their scrape interval, the series type, like is this a classical histogram or is it a native histogram, and so on and so forth. And we also need to track, as already mentioned, the changes of to metadata over time. And yeah, I should mention that these use cases were gathered both internally in our company, Grafana Labs, but also within the Prometheus community. And we are interested in gathering more use cases. So furthermore, why would we need to add functionality for persisting metadata in Prometheus? We find that Prometheus cannot currently support these aforementioned use cases efficiently. As I alluded to already, open telemetry resource attributes are currently persisted in Prometheus, but they get encoded as labels of the target info metric. And one is that you cannot really attach too many labels sensibly. They can be on the other hand be many open telemetry resource attributes. And the other thing is that consuming these labels on target info is not easy. So like typically OpenTelemetry users, they want to see certain of the resource attributes. Typically they want to see where the metrics come from, like where are they produced. And to solve that in Prometheus currently, you have to basically write so-called join queries, as Brian Boram talked about earlier. And that's many users think this is too advanced, this is kind of too high of a bar. And if that was not enough, you can also hit so-called join conflicts when, say, OpenTelemetry resource attributes change, which they can, because when, for example, an OTel resource attribute changes, the corresponding target info time series, which is here joined on job and instance. Job and instance remain the same, but another label changes. So you end up having, for 5 minutes, 2 copies of basically the same target info series. And joins joins on that job instance combination will fail for those 5 minutes due to because the binder operator doesn't know which of the series to pick. This problem is actually that problem of join conflicts will actually be solved by the upcoming info function, assuming that is merged into Prometheus, but still. And as I also mentioned, there's this other case where you kind of hack metadata into Prometheus by putting labels on series. And that's a kind of a solution, but it's difficult to manage because it leads to series churn when these labels for metadata change. And another issue is really that you kind of violate the principle that a series' label set should identify the series, and you shouldn't have extra labels which are not part of the identity. And you can kind of get like clutter in the UI because of so many labels. So, our main goals with this metadata store that we are trying to design are to have a unified metadata store to solve all reasonable use cases, both those of today and those of tomorrow, and to also have an easy user interface for getting metadata in there, i.e. ingestion, and to get them out, i.e. querying. And here I'm going to hand it over to Ganesh.
Yeah. So now we are going to dive into how we are planning to store this metadata. So the idea is simple. The metadata is like key value pair, and what else is key value pair? The time series. So we see metadata as, let's say, another set of time series, but we don't store it with the series, but we have a separate index and a separate storage for these metadata. So once we see these metadata as time series, a lot of other design decisions kind of become intuitive. We prototyped this during an internal hackathon at Grafana Labs, and that's where the inspiration of all we are going to talk about next is coming. Besides us, we had Jesus, Ying, and Jihao as our team members in this hackathon. So when we think of metadata as another series, it's pretty simple to replicate that in storage. There are a lot of things on the screen right now, but we just need to focus on the blue and the purple boxes. The blue box on the left side, we have the series, which stores all the information about the series, what compressed sample chunks are associated with this, and all those kind of stuff. And we have inverted index. So Brian mentioned postings this morning. So we have the postings and all the information related to it in the storage. So to replicate the index for metadata, we just need to have the metadata series and the information associated with it. I call it simplified because we don't have samples here. It's just the labels and the time ranges when it was active for some series, but we'll come to that later. And we have the inverted index for metadata. So now we can query the metadata if you want to query it separately. But this is common for all the proposals that's coming up next. But one thing we need to think about is how will we map it with the series? There are many different ways that you can map with series. And one thing that remains constant is like one time series can be associated with multiple metadata. Multiple as in like there are different instances of metadata. Let's say hotel or the custom metadata that you want to add. Prometheus may want to add some metadata. All of them can be like separate metadata series. And you want to store what time ranges they were active, because when the metadata changes, you don't want to attach the old metadata when you query for the latest time. So one of the ideas shown in the screen right now is like, we can map it directly with the series in the storage. Like we have the series information in the storage, we can just store the metadata IDs with the series. That's pretty simple. When you look at the series, you know which metadata it's associated with it. But what if you want to have all the series metadata in a single place? So we can have a lightweight map in between. Instead of storing with the series, we add an additional map in the index where it stores the series ID and the metadata that's associated with it. But what if you want to go further? What if you don't want to store it with the series? Because now when you're querying samples, you want to know what metadata was associated with that particular sample. So the idea is instead of storing it with time series, why not store it with the samples? Like we have compressed chunks, like a chunk can have, like, say, 100, 200 samples. We can use the header to store what metadata is associated with them. These are just a bunch of ideas that we are floating around, but we haven't decided on what we're going to do next. Like all of this brainstorming happened in like last month. And what's the exact benefit of having metadata? If you notice, I'm representing metadata to be something very small compared to the number of time series that we have, because the metadata is going to be shared among many time series. And when it's shared among many time series, one problem that Arve mentioned is if a metadata changes, it's going to change labels of many, many time series. So one change in metadata can cause churn of, let's say, billions of time series. So for a brief moment, like until the time series is in the memory, you might want to give more resources. There might be doubling of series or triple, maybe not triple, but at the worst case, it can double the number of time series. But by having this metadata stored separately, the churn is going to happen in the small set of metadata. Maybe the series will say that, OK, it had this metadata for this time range, some other metadata for this time range, but that's pretty lightweight compared to just replicating the time series. So we could have done with relabeling, attaching it to the time series, and doing some magic around it. But the whole idea of the storage is making it very resource efficient. And we have a very detailed design doc on all of these proposals out. We announced that in Prometheus developers mailing list. If you're interested, you can scan this QR code to go to the design doc. But we'll share the slides, so you don't need to look at the links right now. And I hand it over to Arve.
So one problem we have to solve is basically how to ingest metadata. And if we think about OTLP, which is the OpenTelemetry protocol, which is basically remote write for OpenTelemetry, which Prometheus supports, then we don't need to think about how to receive metadata from the client, because it's there in the resource attributes directly. So we then just have to think about how to convert the OpenTelemetry resource attributes to the Prometheus internal metadata format. But when it comes to receiving metadata outside of OTLP, like when scraping time series, for example, then we need to think about the format for representing the metadata. And as you see in the example here, one way we thought of maybe solving this is to have a scheme where we prefix the labels with a _meta and then _family name, because then those labels would be used for representing metadata. And at the bottom of this, towards the bottom of this slide, you see that we kind of foresee that you have the series labels themselves, but then you also have collections of metadata key value pairs, where you will have a family so that you can partition the the metadata according to their origin, let's say. So like, for example, I'm thinking that open telemetry resource attributes should be in a family of their own. So you can kind of tell that these are open telemetry resource attributes. And then there's the question of what should the UX look like on the query side. So we're thinking that metadata should not be attached by default to query results. And we could mirror our idea for the ingestion format by having special meta label matchers that are again prefixed with a _meta_ family name. So in that way, you would analogously to normal label matching, match the metadata key value pairs that you want. And now we would like to play a short video of from a hackathon we conducted internally at Grafana Labs, because during this hackathon we developed our very first prototype of the Prometheus metadata store. So Jesus Vasquez is the one narrating this demo.
Yeah, I'll play it from my local machine.
Hello there. The demo we have today consists of two scenarios. Scenario 1 is going to be a modified version of the Cortex load generator writing a set of sine waves to our Prometheus server. These sine waves have a normal series label called wave, identifying the actual wave. And then they have a meta label, which is prefixed by the __ meta label __ prefix, identifying which node is producing the wave. So if we go to our Explore UI and we query the time series we want and we filter single-digit waves, we are going to get waves going from 1 through 9. But here we'll notice that no meta labels are attached to them. The reason for this is that meta labels no longer are part of the series. They are now in a meta store. So if we want to get them, if we want to see the value of those meta labels, we have to add them to our label selector. Just like this, we can say, we want this label selector and I don't care the value, I just want to select it. So we run the query and we're gonna get again waves 1 through 9, but this time we're gonna see the actual node that is producing the waves. And we're gonna see that some are being produced in one node and some are being produced in a different node. So just like before, we can now filter using meta labels. So we can go to our label selector and say, I only want a series coming from this node. So we run it, and we get that there are only two waves being produced in this node. And on top of these, we can also aggregate over time using meta labels. A sine wave goes from -1 to 1, and we only had 2 time series in this query. So if we sum by the node IP, in the same query that we had before, is gonna go from -2 to 2, proving that it's working as expected. All right, then we have scenario 2, which is very similar, but this time we have an auto instrumented application that's going to be writing to an auto collector that's going to be writing into Prometheus. The auto instrumented app is producing this metric called HTTP request total, with normal series labels, handler and job, but then it's going to have a set of resource attributes that are common in the open telemetry community, like the availability zone, the cluster name, the namespace name. When these resource attributes get into Prometheus, Prometheus is going to get them and prefix them with the meta label prefix to put them into the meta store. So we can run the following query. We can get the meta label matchers out first to see the actual series that is being produced, where we only have the normal series labels, and then we can add our meta label matchers, and we will be able to see all the data that is coming in. Any of the meta label matchers can be removed, and we will just see the data that we selected.
Yeah. So a big disclaimer here is this is just a prototype and design is not fixed, so things might change drastically for the final version.
Hello there.
Yeah, and how can we get involved? We really need help from the community to help shape this interface for querying and ingestion, and if you have ideas for storage, the first thing you might want to do is join the CNCF Slack called Prometheus Metadata Dev, where we plan to have most of our discussions on all this work. And chime in there, tell us how you want to use metadata, if there are any use cases that we haven't covered in the design doc. And also leave your feedback or suggestion on the design doc that is open right now and the future design docs that we will have, and also suggestions for ingestion and queries. And if you're interested to like hands-on work on this in designing and coding, we are more than happy to help you with that. So thank you. And you can scan this QR code if you want the slides right now.
OK, we have the first question right away.
Hey, thanks a lot for the talk. Looks really cool. You said that by default, you're not going to include the metadata labels and their values in the result set, and you only start including them as you request them. I wondered if you could kind of explain why you're going down that route at the moment. It seems to me like if we just included them all, that might be a bit more consistent with how labels already behave. And now we're going to have to learn a new behavior, and we'll have to know that these things even exist in order to request them.
Okay. Yeah.
I guess it would be backwards incompatible, right?
Yeah.
If you would just add them by default.
Yeah, so my thought here is like we are intentionally separating these out. Joining metadata to series with this new storage is not going to be cheap because you have to join them every time you query. So there is some performance implications. And if you add all the metadata can be very verbose. If you add those every time you query, the queries will probably get more complicated to filter them out. So that's one of the thought why we don't attach. And if you really need some metadata, you explicitly add it. So if there is going to have some like breaking changes, maybe it will come with breaking changes.
Yeah, and it will also lead to a lot of UI clutter, right?
Oh, yeah.
A lot of noise.
Oh, yeah,
So it's like,
a lot of noise.
It's like this, as I said, probably there's a lot of metadata you don't want normally, you know. But sometimes you kind of want to reach in there and find something you're normally not interested in. So it's a bit, we think it's a logical separation.
Yeah, I think we have many more questions. Yeah.
Hi. I noticed that you were focusing on metadata that are supposed to be included as query filters. But there's also use cases where we need the metadata not as a filter, but it's useful for calculations of rates and increases. For example, the created timestamp and the last sample ingested. Are you planning to have another approach with this kind of metadata, or is this going to be the one that you are aiming for?
Yeah, so that's a good question. In the design that we have out, it has a drawback that storing, let's say, the created timestamp or the some information may not be feasible to store with this metadata store. Things like scrape interval could be stored with this metadata. And if it's some kind of standardized naming that Prometheus uses, then it could always use that information to do some intelligent rates, for example. But for things like created timestamp and some other stuff, maybe we need to extend the TSDB a little further than what's in the design right now. But yeah, we need more design. Okay.
So I really like the demo for the resource attributes. And I think this works well because resource attributes don't change. But when I hear metadata, I always think of exemplars, to be honest. So that's the first thing in my mind, which is metadata that is different every single time you scrape. So I'm wondering if that would also be something that would be covered.
Yeah, I think someone asked that question on design doc as well. And my response is like, if you see metadata is like yet another time series, just that it's stored separately and linked with the time series. If you start to add exemplars in the metadata, it's again going to be a very high cardinality on the metadata side. And it's going to keep churning. It's going to become yet another time series on the side. But to keep it focused on, like, it's some additional information that describes the series. But exemplar is like it describes some event and points you to an event. So there is that logical separation. So maybe exemplars don't fit this metadata model. Yeah.
You said that you wanted to add this __ meta prefix to metadata labels for Prometheus text exposition format. And as I know, this meta prefix is already used during relabeling, and relabeling usually drops all the meta labels which start with __. How did you think about this, and how?
No, like the big disclaimer was all of this is brainstorming, especially the __ meta label that we talked about. We chose that because in hackathon you have less time. That was the easiest way to put metadata into the storage, and we found this idea looks really cool. So we haven't thought beyond that. It just looks good. Maybe it'll work, maybe it won't. And I guess that is where we need help from the community to help fix any drawbacks or things that we haven't thought about. So as I said, this may not be the final design, but the storage that we are designing doesn't depend on how the labels are done. So the interface is still a big to-do.
My question is in the context of stability of your time series naming and labels, because often when your service changes names in your metrics that it exposes, then your dashboards and your alerting breaks. Do you think like this metadata could be used to have some status of your metric, like saying like this is a stable metric or this is a deprecated one? So with a deprecated, you could give like hints to your dashboarding and alerting that maybe you need to update that. Is that an option?
Do you want to answer?
Well, I think that's like a good example of metadata.
I think you just gave another solid reason why the metadata is going to be useful. It makes complete sense. It's like you add additional information about time series, and you could make use of it in
it's like additional information which is not part of the identity of the time series.
Yeah, so it makes complete sense to add them as a use case.
Over here? Sorry, here, in the back. Doesn't matter.
Okay.
Have you thought about if this could maybe get rid of info metrics? Like, is there a migration path to sort of migrate info metrics into metadata?
So I guess we're thinking that this is probably a better solution than infometrics, but so far we've thought we will have to keep supporting infometrics for at least for backwards compatibility, right? And maybe there are even cases where infometrics are still more suitable. I'm not sure.
Yeah, and I don't think this metadata is gonna be ready in like few months. It's gonna take a little bit of time to design and actually have it in some release. So I think infometrics is here to stay for some time.
Mm-hmm.
All right, thank you. Yeah, I will definitely, I think, go to your Slack channel and give some ideas and feedback. And I have a million questions already around, like, conflating filtering versus what labels you actually want to show, and so on. But one question for now: have you thought about making like some of those metadata labels would clearly have a special, always fixed meaning, like help and type? Would they just be reserved label names, for example, or would they be an even more special kind of stored value that's not just a key value pair?
Yeah, maybe like if we have different families for metadata, maybe we can have a special Prometheus family of metadata, which are like metadata that is produced by or stored separately by Prometheus for its use. So maybe it can go under the Prometheus family, and after that, once you attach something specific to Prometheus, I think you can use anything that you want, like type, help, and I think it's just Prometheus that needs to know and document it so that users can query for them as well. So I think it fits in that model as well, a separate metadata for Prometheus-related stuff.
And I guess my question is exactly the opposite of Udis. There are like
resource attributes and there are data point attributes in OpenTelemetry. And data point attributes could be like the client ID, which is a very bad idea in storing in Prometheus. But do you think that this here opens a door for more high cardinality storage? Like, I want to know what is the average, I don't know, what is the latency, the P99 for a specific client throughout of my services?
Do you have an answer?
Yeah, I mean, it's a bit of a tricky question to answer. I mean, OpenTelemetry data point attributes are directly converted to Prometheus metric labels at the moment. So I think first of all, it's like how do you tell which one of them should not be made into metric labels and instead metadata? I'm not sure how you would make that distinction.
I guess the question is, would there be a point where users won't have to make this choice? Like that storage would be designed in a way that that kind of granularity is stored in some way.
But I mean, do you mean that this client ID, which is a metric data point attribute, it would not become a metric label like now?
If there is a way for it to become, and still not be a problem because of the high cardinality that it brings.
I guess that's not. I guess it's not really what we're trying to solve, right?
Yeah, we're not really trying to solve like the high cardinality problem of Prometheus, but the problem of metadata, which in turn helps churn in metadata. Yeah, maybe it's a longer discussion for helping in high cardinality.
Good questions, though, right? Like, let's sit in that question. Thank you. I think that's all for the questions. Thank you so much.
Thank you.
Yeah,
Thank you.